Alright guys, I'm going to go ahead and get started with this video. So what we're doing in this video is we're trying to optimize area. And to optimize something, here's my definition, would be given some amount. Okay, you're trying to create the best that you can with that amount. So it depends on what you're talking about, but in this context we're talking about fencing. Okay, so we're given, it says a rectangular pin is made with 100 meters of fencing. So we have 100 meters of fencing to create a rectangular pin. And if we're going to optimize the area of that pin, we're trying to create the biggest area that we can. So for example, in some other contexts, you might be trying to optimize costs. So you're trying to reduce or minimize the amount of cost that it takes to produce something. In this case, we're trying to optimize area. So we're trying to create the biggest area that we can given 100 meters of fencing. So there's so many different dimensions that we can actually apply to 100 meters of fencing. We can make it maybe 50 foot, like a rectangle 50 foot long, and then 50 foot back, but that's already 100 meters of fencing, so there's no width there. Or we can make it 25, 25, 25, 25 all the way around. That would be 100 meters of fencing, and maybe that would maximize the area. So the question is, what's the biggest area we can create using 100 meters of fencing? All right, so this paper starts off with all kinds of instructions, and honestly, I'm going to skip some of the ways that they word things, and I'm going to show you how to do it. It's the same way, guys, but I feel like sometimes when you go through something too slow, it's hard to see the big picture. So again, the question is, what are the dimensions that we're going to put on this rectangle to maximize or optimize the area? So you want to start off, and you want to realize that area is just simply length times width. That's all area is. It's just length times width. And now, we've been working with quadratics, so keep that in mind. The idea and what we're going to do to simply optimize area is we're going to have to turn this into a quadratic. Right now we have two variables. We want to reduce that down to one. So with that being said, let's go ahead and apply some dimensions to this rectangle here. And it's just a picture, and you're going to want to start off by drawing a picture if you aren't given one at the beginning. Now, we have 100 foot of fencing, or 100 meters of fencing. We don't know what dimensions to give it, so we're just going to say that's the width, and this is the length. We don't know how long the length needs to be or how long the width needs to be, but we do know that to create the fencing around this rectangular perimeter, we have two widths and we have two lengths. So we have 2 lengths plus 2 widths, and that has to equal the 100 foot of fencing that we're given to use. So that equals 100 foot of fencing. Now the idea, again, to keep this all in perspective, we're trying to create an area equation that looks like a quadratic, so we can maximize it here in a second. But we have two variables, so we need to reduce this down to one variable, and we're going to do that by using this equation. Okay, so what you want to do is you want to solve for either the length or the width and put it in terms of the other variable. So for example, if we want to solve for the width, then I'm going to have 2w equals, and I'm going to subtract the 2l to the other side. Okay, and then I'm going to divide by 2. So I'm going to end up with the width in terms of length is negative L plus 50. Now width, so what this is saying is width is negative L plus 50. So bring it back over here now. Area is length times width. So if I'm going to create this and cause it to be a quadratic, then I'm going to use this idea right here. Width is negative L plus 50. And I'm going to plug it into this equation. So instead of writing width right here, instead of writing W, I'm going to write negative L plus 50 because that's what W is. Okay, so I'm going to have area is length times, and here's width. Normally it would be just W, but instead of writing W, I'm going to write negative L plus 50. So area is length times, there's width. Okay, width is negative L plus 50, so here's width, negative L plus 50. I'm going to multiply this out, so distributing, I have L times negative L, so that's negative L squared, and then L times 50, so that's plus 50L. And right here it says express the area as a function of length and the width. That's your first objective, really. And here it is. The area, and this really should be A of W because I used W instead of X. A of W, the area is negative L squared plus 50L. All right, so the next, that's your first main objective. After that, it says, enter the function into the calculator and sketch a graph of the function in an appropriate viewing window. Okay, so let's go ahead and turn the calculator on. I'm going to close this all out and start from a fresh point so you guys could see what I'm doing. All right, so let's go ahead and put it into the calculator. I'm going to zoom in on this part now that I have this area function. Okay, so we're here. I'm going to go ahead and type in negative x squared plus 50x, graph that. And a lot of people will look at this and say, look, there's just a line. I can't see anything. Again, that's because this quadratic we just created is not small. It's a big quadratic, okay? So we need to use what I talked to you guys about in class. It's negative b over 2a. So we need to use negative b over 2a to find out exactly how big this quadratic is. So negative b, and this will help us find our vertex. Negative b is negative 50 over 2a is negative 2, and that equals 25. So my vertex is going to be at 25. So let's go over here real quick. My vertex is going to be at 25 comma something. And if I want to find out what that something is, I would just take that 25 and I'd plug it in right here. Okay? So let me go ahead and do that real quick. It's 25, so 25 squared. Let's see. I'm going to use a different color. So right here, 25 squared, that's 625. So negative, this is going to be negative 625 plus 50 times 25. That's 1,000. Oh boy, let's see if I can do this in my head. I feel like that's 1,250. Okay, and then when you add these together, that equals 625. Okay, so what that's saying is that when the x value, or in this case the L, when the length is 25, then the maximum area is going to be 625. Now, in a strange way, we've actually already solved the problem. Okay, so some of you guys that are really good at with algebra and you understand what you're doing, you understand that that is the solution, because that's the vertex and that's the maximum. That is the maximum area that we could possibly create. When the length is 25, the maximum area is 625. And that would be enough to actually solve the rest of this. However, I'm going to bring it back to this calculator real quick. Okay, so there's the vertex. Let's see if I can... All right. And again, we were talking about how we can't see the line. So I'm going to come over here, window, and change my window settings to go anywhere from 0. Now the maximum was 25, so that means if it reaches the top at 25, it's going to reach back down to the bottom at 50. So 0 to 50 I want to see, and then anywhere from a y minimum of 0 to 625 is the maximum. I'm just going to do 650. And that should be a really good window for what we're viewing. Okay? And again, this point right here at the very top, that is 25 comma 625. That is the maximum. All right? So let's just go ahead and follow along with this paper. I'm going to zoom out real quick. Okay, and I realize you can't really see the graph that well on this calculator probably while you're watching this video, but let's go ahead and fill this stuff out. You don't need to. You got a good view of it. Here it is, starting at 0, goes up to a maximum of 625 when the length is 25, and then back down to 0 when the length is 0. Okay. So I'm going to just put this to the side, and we're going to create a just sketch. It just says sketch a graph. So it goes from 0, 0, up, comes back down. Okay. And again, we were talking about this is the maximum right here. There's a maximum at 25 comma 625. 25 comma 625. All right, now if it starts at 0, 0 and it reaches its maximum at 25, 625, then to come back down to 0, it's going to take 25 more. So the x minimum goes from 0 all the way over to, if this is 25, that should be 50. Okay, don't worry about the scales. The y minimum, that's 0, and that's the maximum height or maximum area of 625. So y minimum can go anywhere from 0 to 625. So find the maximum area of the pin. That's what I'm saying. For those of you that were good with algebra, you see that is the maximum area. So what's the maximum area of the pin? It's 625. 625, and we were talking about meters, so we have meters squared. Find the dimensions, which will give the maximum area. Okay, well, that's also answered as well. So if the maximum area is 625, how do we get that maximum area? Come back over here. It says when it's 25. Okay, well, what is it? Here's what we just graphed. It is length. When length is 25, area is 625. So length has to be 25. So what are find the dimensions which give the maximum area? Length has to be 25. That's only one of the dimensions. So use that dimension, okay? Use that dimension to find the other dimensions. So think about it. Here's your length. Question is, what's the width? Come back up over here. It says that 2 length and 2 width has to equal 100. So if the length is 25, you've got 2 times 25, so that's 50, plus 2 width equals 100. Unfortunately, I'm going to have to solve this. Let's see. 2 times 25 plus 2 times w equals 100, like that. I'm just going to solve it right above. So that's 50. So we have, I'm going to subtract the 50 to the other side, so I have 2w equals 50, divide by 2. So width also has to equal 25. And there's your answers. Width equals 25. So find the maximum area of the pin. That's 625. Find the maximum, or find the dimensions that create that maximum. Length is 25, width is 25. Okay, so that's one complete problem. Now I'm going to go through the second one with less explaining so you guys can get the big picture. I like the second one because it takes a little bit more thinking. It says a rectangular pin is made with 100 meters of fencing again, but this time it has 3 sides. The fourth side is a stone wall. Okay, so in other words, if this is a stone wall, if this line right here is a wall, then we don't need to fence that wall. So we have now a width here, we have a width here, and we have a length here. So we have 2 widths and a length. So creating my 2 equations, one is area equals length times width, and the other one that we're going to use actually looks like this. 2 widths plus 1 length equals the 100 meters of fencing. 100 meters of fencing. I'm just going to put 100 so we don't think that m is a variable of some kind. And now my objective is to solve for one of these variables so that I can plug it into this area equation. So right now I don't see any coefficient to L, so I'm going to go ahead and solve for L. I'm going to subtract 2w to the other side. So that's going to be L equals negative 2w plus 100. Again, without much explaining, I'm going to take this and I'm going to plug it in here. I did all the explaining on the last problem. I'm going to plug it in here to get an area equation with one variable. So instead of writing L right here, I know that L is negative 2w plus 100. So instead of writing L, I'm going to write area equals, now here it is. That should be L, but I'm not going to write that. I'm going to write negative 2w plus 100. Negative 2w plus 100. That is L. L is negative 2w plus 100 times w. Okay, so to finish off and write the complete area expression, I'm going to multiply the w in, so I have w times negative 2w, so I have negative 2w squared, and then w times 100, so that's plus 100w. And that's my equation that I'm using to maximize. That's my area equation. All right, so to maximize this area equation, remember the maximum is just the vertex. So without even using the calculator this time, I'm going to do it all just by finding the vertex. So negative b over 2a helps you find the vertex. Negative b in this case is negative 100 over 2a. 2 times negative 2. Which is negative 4. So negative 100 divided by negative 4 should be 25. Yes, 25. Okay? So 25, so when I think about my function, again, this is the vertex, what I'm just now solving for. So 25 comma something is my vertex. So when my width is 25, I get a maximum area of something. So here's my quadratic. Something like that. When my width is 25, I get a maximum area of something. That's all it's saying. So let's see what that maximum area is. 25, take it, plug it into here. So I get 2,500. That's 25 times 100 is 2,100 or 2,500. Plus, okay, so I got 25 squared. That's 625 times negative 2. So that's negative 1,250. So the maximum area is going to be positive 1,250. So positive 1,250. And honestly, again, I didn't even plug it into the calculator. So look at what I did. I just found the vertex. So what does that tell me? All right. So let me finish writing this out. It tells me that it starts at 0, 0. Okay, so the x minimum, 0. X max, well, it reaches its max point at 25. It reaches the maximum area after 25, okay? So it's going to be back at the bottom at 50. So x max goes to 50. The y minimum goes from 0. Y maximum, 1,250. Don't worry about the scales. Find the maximum area of the pin. We've already got it, 1,250. Find the dimensions which give that maximum area. Well, we know that, again, here's what we just graphed. It's the width is the 25 right here. So we know that the width is 25, and I'm going to use that width of being 25 to answer what's the length. The question is now, and the length equals what? We'll take the 25, right, and plug it in right here. So width is 25, so that's 2 times 25, which is 50. And I'm going to subtract 50 from each side. Okay, and I'm going to get length equals 50. So when the width is 25 and the length is 50, I get a maximum area of 1,250 foot for that fence. Okay, hopefully this video helped. I will actually post 2, one from last year as well, to help you guys. But if you have any questions, make sure you come in the morning, and hopefully I can help you there. All right.